Hello, everyone. Welcome back. Welcome back to our online online learning. And in this video, I will show you another lesson about solving the pathways problem before I get into the binomial theorem. So let me read the first question to you. Determine the number of pathways from A to B without backtracking. So let's say you have to go from point A to B here. And you see this is a three-dimensional picture. It's not one it's not like two ways direction or one way direction, right? Because think about if you in the building of a shopping mall or whatever, right? So this is a three-dimensional shape, and because it is three dimensions, we have to have a way to calculate it in 3 dimensions. Now, usually when we talk about 3 dimensions, we think about the volume. And the volume is equal length times width times height. And therefore, if you want to travel, let's say the first floor, the top floor in here, down to the bottom of the, how many floors is that? 1, 2, 3, of the third floor level of the building, let's say like that. Then you have to account into this thing. So the way you do, you will count 1, 2, 3, 4 blocks, and you will put in the letter, let's say you put in the letter is, this is you go is, right? So is, 4 letter is. And to get down to B, you also have to go down. Let's say you go from here to here, right? A to here. So that is go east, right, in this direction. And to get to here, you have to go down as a down arrow direction, which is involve the height of the building. And when you go down like this, in direction, you say, I'm going to go south, south, south. So you put in south, south, south. And to get to B, let's say you go from here to here, then your arrow will be like this, and it means you have to go north, right? This is the north direction, right? North. So south and north. So how many blocks north you have to go? And 2 of them. 1, 2, right? And this is 1, 2, 3. So you have 3 letters of S and 2 letters of N. You can treat this as the permutation problem, right? Because there's no way, if 2-dimensionally hard, like how can you count how many possibilities to do 3 dimensions? So let's use the math here and calculate it. So on this is your total of your letter is how many? We have 4 add 3, 7. 7 add 2 is 9. So the answer will be 9 permutation or 9 factorial. And of course, you have to divide by the same letter, right? So you have 4 letters, which is 4 factorial for the letter east, and 3 letters for south, so 3 factorial for south to avoid the double count, right? Remember, that's the way we learned in the permutation or combination before, right? So now, the next have 2 letters the same, so you divide by 2 factorial. Now the answer will be, this you have to use a calculator, okay? You can do by hand as well, But that is a lot of numbers. So let's just use a calculator. So we do 9 math, and that is 9 factorial. So we do 4 for factorial, right? And we get that easy number. See how big it is? Now we're going to divide it by 4 factorial and divide by 3 factorial. And another 2 factorial. So now we close the bracket, and that should be on your calculator, and we enter. So the answer is 1,260 ways. So that's the answer. 1,260 ways you can travel without backtracking. It means you just go forward without backward, right? So you go from A to here. So go east, and then go south, and go north. And that's the way you do it. So I provide you another picture of the shape of the 3-dimension, how you solve the problem. Let's go to the second problem. Now, in the second problem, I would like to show you how you can answer in 2 ways, and then we will check, right, if they are come up with the same answer. Now, if they are the same answer, of course, then we do it correctly. If the 2 ways we're doing have a different result, then of course, it means something we need to take into consideration, right? So let's try it. I don't know myself, to be honest. So let's say, now, let me tell you, if you have a diagram like this, right? You want to travel from A to D and see how many ways, right? The question still, how many ways? How many ways to travel from A to D? So from this point to this point. Now, you can split this into a different shape. And let's say if you're talking about, you go from A to C to D, right? You go from A to C to D. So I'm going to mark here A, C, D. Then you will have to draw another shape like this. So that is for this square shape, okay? Right? And I have to use another light color. So let's say you will shape this like this, right? So let's look at just the shaded area. I don't know if you can see it from the screen, right? This is the shaded area. So just look at this corner, right? This square corner represents, so this is A, and this is C, okay? Now, how many blocks for this? 3 blocks. I'm going to write 3. And 3 for this, so I'm going to write 3 as well. So that's one shape, like this one. From here to here to here to here, okay? Now, the second shape, because we're talking about ACD, then you look at the rectangular, right? Not triangle, like, I think I made a mistake last time. It's rectangular. This one to this point, to this point, to this point. So another shape here. And you can draw like this, right? Let me draw this. Okay. So this is point C. So you go from point A, C to D. And how many blocks for this one? You have 1, 2, 3. So this is 3 and this is 2. So that's the one shape. Okay. That is one possibility, right? And you can use a permutation for this, which is for this one, you can say this is 3x3 is 6 factorial divided by 3 factorial and 3 factorial, right? So that's the way we count if we use permutation. Now, let's leave it for now. So that is one block here, right? So we're done with that. Now let's do the second one. And remember, m way times n way, so we time. How many blocks for this? Is 3 and 2, so will be 5 factorial divided by 3 factorial, 2 factorial. And remember, these two things time together, okay? So I can tell you this one look like, so 15, I don't remember, let's do it. So 6 factorial, 4 divided by 3 factorial times 3 factorial, and let me enter it. You get 20. So you get the first one, you get 20 times with the next one, you have 5 factorial and divided by 3 factorial and 2 factorial. And you close the bracket, you get 10 for this one. Okay, so this number will become 200. So that is one way if you travel from A to C to D. Another way you can travel from A to B. So let's write down AB. So another way, right? Another way. You can travel from A to B to D. So ABD. And ABD is this shape of rectangle, which is 1, 2, 3, 4, 2, right? So the rectangular here have 4 blocks here and 2 blocks here. So the total will be 6 factorial divided by 4 factorial and 1, 2, so 2 factorial. Time with this block, right? Now you look at the BCD block, right? This one, B here, and this one here. So this one here have 2 blocks on the top and 3 blocks here. So it's 5 factorial in total divided by 2 factorial and 3 factorial. So this will give you 6 factorial divided by 4 factorial times with 2 factorial and the answer is 15. So for this one, the answer is 15. And for this one, the answer will be 5 factorial divided by 3 times 2 times 2. So that will give you 10 factorial, for 10, number 10. So this time together will be 15 times 10, which is equal 150. And because either you can go ACD, go this way, or you can go ABD. So either or, and in math, either or, it means you have to add them, right? Instead of multiply, we will add either this one or the other one. You have 2 possibilities here. So let's add them together. 200 adding with 150. So the total of number of ways will be 350 ways, and that's the answer. Now, you might not believe what I'm showing you. So to make you believe what my teaching is right, I'm going to test, right? I'm going to use the adding way in Pascal's triangle, like we did before in the previous lesson. And if you forget my lesson, you can rewind the video for my first video to see part 2, right? We can try that. So let me show you the second way in here, how we calculate it. So if you travel this way, you count this in number 1, 1, 1, 1, right? Because you not change direction. If you go down, you also count this in 1, 1, 1. Now, when by Pascal's triangle, we're going to add them. So at the corner, if you want to go from here to here, you will say one way this way, go right and down, or you can go down first and then right. That's 2 possibilities. You put in this corner number 2, right? Now, the same way you will add 2 at 1 is 3, 3 at 1 is 4, 4 at 1 is 5. 1 at 2 is 3, 3 at 3 is 6, 6 at 4 is 10, 10 is 5 is 15. And this should be 15 and 15 as well because you go one direction. So now you get 1 at 3 is 4, 4 at 6 is 10, 10 at 10 is 20, 20 at 15, this is 35. When we go up here, 35 at 15 will be 50, right? 50. And 50 at 15 is 65. Now, when you go down this way, this is 20, so this should count at the same direction, which is up to here, you have 20 way to go. So this 20 and 20 as well. Now, 20 at 35 will be 55. 55 at 50 is 105. 105 at 65 will be 70, so 170. Now you add this with this, you got 75 at the corner here, in front of here. 75 at this will be 5 at 5 is 10, 80, so this is 180. 180 at 170 is 350. So you can see that either way, we end up with the same answer. You got 350 here and 350 here. If we do this Pascal triangle application, or we can do like permutation, splitting the shape like that, we end up with the same answer, 350, 350. So our math problem solving must be correct. And you should trust me now, right? So I hope that you will register to our math courses online on July 3rd. We'll be get ready, school will get ready for Math 12 senior student. And if you are learning from different levels, but if you like it, you want to understand the concept of math or for review it or whatever, you can just register. And I welcome on the international student as well. Okay, so we're done with this and we got 350 ways. Now let's do the last question here. So the last question, I will talk about determine the number of ways for the checker. Let's say we have a checker here, right? To reach the position marked on the sideboard. So if you look at here, I mark this, right? This is the marking divided the board from the right and from the left. Checkers travel only on the dark space. Now, because I don't want to color it, right? So therefore, on the marking here, an X is like replace for, it means the dark space. Okay, so it's for replacing it, dark space. So now, I will just remember now this, the box have an X here is the dark space we're talking about, okay? So determine the number of ways for the checker to reach the position marked on the sideboard. Checkers travel only on the dark space in one direction until it gets to the other side, moving one square at a time and no jump. So we're not going to jump from this square to another box with the different distance, right? Jumping, right? So it's just one direction. On the map, it shows you this is a checker. This guy going to travel in one direction only. There are how many ways we will have to be decided, right? Now let's think about this. Let's think about this. If the checker start from here and go this way, see one way, or it might go this way in one direction, right? So let's mark here at number 1. That doesn't work. So let's mark here as number 1, right? It go in one direction. If it keep going this way, this is number 1 and number 1 direction because it's not jumping, right? It keep going one direction. So all of this box is supposed to be number 1 direction, only number 1. Okay, fill in with number 1. One direction, right? And you can see that the arrow say this is one way, one direction, right? No jumping. And only go in the box have a black space, which is the X I checked it, right? Now, if it go this way, then this also count at one way. And it's not going to jump from here to here, right? Even though we have an X here, it's not going to jump like that because it's not allowed. So let's say in order to get from here to here, how many ways he can do? He can either go this way and to get down here, or he can go this way and to get down here. It's still one direction, right? It's not jumping and it's not 2 directions. So either he go this way and get here, or he can go this way and get here, and still one direction, right? Still satisfy the condition. So there are 2 ways to get down to here, to this X bar. So now, if he go from here to here, then this is one direction as well, and he have 2 ways of doing it. So let's fill it in. Now, if he go, okay, so let's say this is, in order to get from here, he go 2 ways, right? From here to here and from here to here, so 2 ways. And he go in one direction, so 2 ways to get here and 2 ways to get here. As well as if he go to here, right? Then he have 2 ways as well, right? He have 2 ways as well because from here to here. So now, if we say, what about he travel to here? Now, and to this box, he have 2 ways to get from here to here, right, in one direction. And he also have 2 ways to get to here in one direction, right? No, but let me see. I might make a mistake here. Let's see. If he want to go from here to here, right? Let's say he can go. Actually, he can go this way as well, right? So he can have 1 way to go this and put and get in here, or he can have 2 ways to get in here. So 2 add 1 is 3. Here we go. So it should be 3. Okay. Now, if he go to this box, then the total down here to 3 way already, and he can go in one direction and get to here as well. So he have 4 way of getting here. So to get down here, he have 4 way, but he also can go one direction up here and then jump to here. So he have 5 way to get here, right? 4 at 1 is 5. Now to go down here, he have 5 way already, but he also can travel one direction, get to here, so he gets 6 way to get here, right? To get to this point, he already have 6 way, but he also travel all the way from here and get to here, so that's 7 way, right? 6 at 1 is 7. Now let's fill out the rest. So to get from here to here, he have 2 way and have 3 way. He can go from here to here. So that count at 5 way. 2 at 3 is 5. Now to get down to here, he have 5 way, but here he have 4 way. Is that right? 4, yeah. So 5 at 4 is 9. So he can jump from here, which is total count as 5 way already, or he can go from here to here, one direction, right? So 5 at 4 is 9 way. From to the square, you can add the possibility here, it's 5 way to get up to here, or you can go from here, or you can go from here to here. So the total here is 9. And if you want to go from here to here and here to here, you have 5 possibility. Now the next one, you have 5 direction, 5 possible way, then you keep traveling this way, you still have 5 possible way. Now get to here, you can have 5 way this way and 9 way this way. So 5 at 9 is 14. And to get to here, right, in this box as well, you can go from this one is 9 and this one is 5. So 9 at 5 again, you have 40 to get to here. And the question asks, determine the number of ways for the checker to reach the position marked on the sideboard. So it means this position, right? So it means you can go to this marked side here by this box and this box. So there are 14 ways here and 14 ways to reach the marker on the board. So in total, you have 28 ways. And that's the answer. So I hope that you can enjoy this video. And thank you for watching. Also, just remind you, don't forget to register for the our online math courses if you enjoy my video. And now I welcome all the students around the world. Just, even though if you just want to get in and learn some concept in math, we open free online education for everyone. And so don't forget to register on July 3rd. If I have to support a lot of students on Zoom, then I might not be able to do it a lot. So maybe registration will have to be restricted. I don't know at some point, but try to get into early and register on July 3rd. I see you there. And the registration is, you can get into my math website, mymathteaching.ca, and register for it. Honor students around the world, if you cannot afford to pay visa student, if you would like to learn North America curriculum international school, and you don't have the condition to pay for expensive, 40,000 per year or 60,000 per year, you learn the same curriculum. I graduated from North America, and I'm designing my course, even though more qualified, like concept, a lot of information. And I said that if I was teaching the same I was teaching in the public school, and I have to restrict the amount of knowledge, because during the time limited classroom management, a lot of factors involved. different student levels, so you never can give full enough information. For online courses, I can give you lots of information, and it's up to you to learn. We give you tools and you can use it in a way. You can rewind and you're never afraid of losing, get lost. Like in school, if you are asking to go to check somewhere else, a washroom, and you come back on the material gone already. But learning online is really a reform education. It was for senior student, I believe. So I will see you there and looking forward to working with all of you. Bye for now, and thanks for watching.